Okay, this is Algebra 2, Lesson 32. We're going to first start off by talking about the quotient theorem for square roots. So we said if we have the square root of 3 times 2, we can break it up to their own square root. Yes? Means the same thing. Well, the same similar rule applies to the square root of quotient. What is a quotient? A fraction for the square root. So if I have the square root of 3 over 2, I can rewrite it to say square root of 3 divided by square root of 2. It is customary to rationalize the denominators of the expression that have radicals in the denominator. We did this in a previous lesson. We said for this to be simplified, there could be no square factors inside the square root, and there could not be a square root in the denominator. So to change this one, we would do what? We would multiply both by the square root of 2, right? So we get the square root of 6 over 2. So we've now rationalized this. Okay, so it has the same value as this. We just rewrote it. So let's look at another example. So we take the square root of 3 over 7. We can say square root of 3 over square root of 7. Then we're going to rationalize it because we don't want the square root in the denominator. And we get the square root of 21 over 7. Alrighty. So let's look at another one that actually has a couple extra steps. So we have the sum. So we take the square root of 2 over 5 plus the square root of 5 over 2. Well, first of all, we're going to break this into the square root of 2 divided by the square root of 5 plus the square root of 5 over the square root of 2. Then we want to rationalize each one. So we want to get rid of the square root in the denominator. So on the first one, I'm going to multiply both by the square root of 5. I'm going to multiply this by the square root of 2. So we simply get square root of 10 over 5 plus square root of 10 over 2. So now we have fractions. And how do we add fractions? We have to have a common denominator. We don't have a common denominator. So I'm going to write this vertically. Common denominator, 2 square root of 10, right, goes outside, 10, multiply 5, so 5 square root of 10. So now I have 2 square root of 10 over 10 plus 5 square root of 10. I have to have the same denominators. Likewise, I have to have the exact same square root in order to combine. So basically, we've got 2 square root of 10 plus 5 square root of 10 all over 10. To combine these have to be the exact same. They are, so then you look at the number outside. We kind of look at it as a coefficient, kind of like like terms. So this becomes 7 square root of 10 over 10 is the answer. So let's do another one. So the first step is we're going to rationalize the denominator. Then we've got to get a common denominator to add or subtract. So we have 3 square root of 3 over 7 minus 5 square root of 7 over 3. So the first thing we want to do is we want to get rid of the denominator. Or we're going to break it up. 3 square root of 3 over 7, square root of 7 minus 5 square root of 7 over square root of 3. So the rationalizes, I'm going to multiply this one by the square root of 7 and this one by the square root of 3. So I get 3 square root of 21. Oh, sorry. Is that right? Did I write the right numbers? Oh, this is a 7 in here. Okay. Over 7 minus 5 square root of 21 over 3. So now I have to have what? A common denominator. And I'm going to write this vertically. Just because it's easier for me to convert. Okay, so the common denominator is going to be 21. So you have 3 times 3 square root of 21. And you've got 7, 5 times 7 times square root of 21. Yes? So basically we've got 9 square root of 21 over 21 minus 35 square root of 21 over 21. Okay? So now, do we see that? So now I can do what? 9 minus 35? Well, the signs are different, so you can find a difference. So because this is bigger, I'm going to do 35 minus 9, which is going to give me 20. Oh, actually, 26. 26 square root of 21 over 21. And it's going to be negative because this one was bigger and the sign is negative. And that's your answer. You'll leave it simply like that. So let's look at the next one. The next example is 32.4. So you have 2 and the square root of 2 over 7 minus 5 square root of 7 over 2. So simply, we've got to get rid of this radical sign from the denominator. Yeah, so you have 2 square root of 14 over 7 minus 5 square root of 14 over 2. Then we've got to get a common denominator. So this becomes 14, 2. So then I get, this becomes 4. Or I can write it 4 square root of 14 over 14 minus, this becomes 14, so it's 35 square root of 14. Then I've got, okay, a negative and a positive. The difference is negative 29, or 31, excuse me, square root of 14 over 14. And that's simply your answer. You leave it in that format. So that's all it is. It's just radical signs. There's still a fraction, but you just got to use radical signs. And you have to remember, you have to treat radical signs like like terms in order to add or subtract them. They've got to have the same number in the radicand has to be the same. And then you simply add the numbers outside. And there's not one to an implied one. Let's look at 32.b. It's congruency. It says only numbers are equal. So 4 equals 2 plus 4. Because 4 is a numeral that represents the numbers 4 and 2 plus 4. Another numeral that represents the same number. So the look at the 2 line segments, A, B, and 4, and C, D. They're both 4 units. So we say that the line segments are congruent because they're both 4 units long. We can say AB is equal to CD. Or we could say line segment AB is congruent, to line segment CD. That's what that line means. We said segment, so this means segment AB is congruent to segment CD. The numbers used to describe the measure of the angles shown below are equal, so we say that the angles are congruent. So we can say angle A is equal to angle B. Or we can say M, which stands for measure of angle A, is equal to measure B. Or we could say angle A is congruent to angle B. So remember, we use equal for numbers or values. So the measures of the angles in one polygon are equal to measures of the angles in another polygon. And the sides opposite equal angles have the equal length. Then the scale factor is 1. So these two angles, polygons, are congruent. So the two triangles are congruent. The sides are equal and their angles are equal. They've just been flipped around or rotated. So thus we see that congruent is a word that means geometrically equal. If we can mentally cut out one geometric figure and rotate or flip it as necessary and place it on top of another one, and it fits exactly, we say that the two figures are congruent. So we use congruent when we're talking about geometric figures. When we use the equal sign, we're talking about numbers. So let's look at the bottom of 32.b. Since to place one geometric on top of another, we can use translations, rotation, or flipping. When we translate a figure, we slide it sideways as necessary. Be careful not to rotate it. So when we slide, we've translated. So look at A and B. They've simply just slided the triangle. Okay, to just flip the page, if we translate this triangle to the right and up, it will flip on top of the triangle. So look at down below. Thus, the triangles are congruent. So we'll write the statement of congruency, but we have to be careful to list the vertices whose angles are equal in the same order. So for instance, triangle ABC is congruent to triangle DEF because angle A and D are equal, angle B and angle E are equal, and angle C and angle F are equal. Okay, so we have to be careful and name it correctly. Alright, so if we rotate the triangle ABC about C, it will fit exactly on top of triangle DEC. So the triangles are congruent. So we say triangle ABC is congruent to triangle DEC. We start it with A and we start with D and we go the same direction. Okay? Sometimes it's necessary to flip a triangle to make it fit. We call a flip a reflection about a line. So if you look at line M, and it's got point X is the same perpendicular distance from line M as point B is. Point Z is the same perpendicular distance from line M as is point C. Point Y is the same perpendicular distance from line M as A. So we can say triangle XYZ is a reflection of triangle BAC in line M. M is the reflection. This means that triangle XYZ was flipped across the line M. Thus, triangle ABC is congruent to XYZ. So note that the corresponding vertices, since we started with triangle A, its corresponding vertex is Y, so we also start as congruent to triangle Y. And you've got to keep them in the same order. So we said ABC, oops, this is triangle, is congruent to triangle, Y, X, Z. Alright? So these two are congruent, these two vertices are congruent, and these two. So you have to keep them in the same order. You couldn't say triangle ZXY because now you're saying Z and A are congruent. So you have to be careful when you do congruent that you list them in the same order. So saying that, let's move on. Congruent triangles are similar triangles whose scale factor is 1, right? Because we said when two similar triangles, we said this, if this two are equal, we said this, let's call this X and this Y, times the scale factor equals Y. But if they're the exact same, the scale factor is going to be 1 if they're congruent triangles. Remember, similar triangles are the same shape, they weren't necessarily the same size. So let's look at example 32.5. This is find X and P. Well, the first thing we have to do is we have to know that they're congruent. And so remember, the two angles are equal, the third angles are also equal. So the triangles are similar, AAA. The sides opposite of a single tick mark angles are both 6 and 6 units long. So the scale factor is 1. So these triangles are congruent because a pair of corresponding sides have equal lengths. And we add the letters S to AAA and say the triangles are congruent by AAAS. Thus, sides opposite the double click mark angles have equal length. Okay? So let's look at it. So we said 6x plus 2 is equal to 12x minus 4. If we look at the triangle, remember this is 6x plus 2, 12x minus 4. So these two are equal, yes, because their angles are equal. So the opposite sides are corresponding. So we say 6x plus 2 is equal to 12x minus 4. We simply solve for x. So I'm going to minus 6x from both sides. 2 equals 6x minus 4. I'm adding 4. I'm just using algebra here, so I know I'm going a little fast. Divide by 6, and you get x equals 1. So if x is equal to 1, so we found x, we're going to find p. Now we know that these two are equal, yes, because we said if these are equal, then these are the corresponding equals. So if two angles are equal, then the third one is also equal. So therefore this is equal to this. And you've got 4x plus 1 is equal to 6. And we know what x is, we can fill it, so it's 5 plus 1 equals 6, so 6 equals 6. So both these sides are equal to 6. So P is equal to, oh, actually this should have said P. Sorry. So P equals 6. So this was P over here, right? So now we've got P. And that's all it is. So just look at, remember, corresponding sides and their angles are equal. On a congruent triangle, the scale factor is 1. Alright, so do your practice problem. And the code for this lesson is 600, the number 600 on the top of lesson 30. Alrighty?